movie that's a big blockbuster out there, Interstellar. Matthew McConaughey and Anne Hathaway have to go find a new planet because of crop failure on Earth. There's not enough food to feed people. And it's packing theaters this week. What do you think of the movie's premise?
Okay. How many in the audience have seen the movie? Just a few. I'd encourage you to go check it out. Actually, it's an interesting premise. So there's been a crop failure, and there are these dust storms. I won't give up the
Yeah, be careful.
Yeah, right, the rest of the story. And basically, Matthew McConaughey is a former astronaut turned farmer, and he's called back to duty as an astronaut and then take off to go find a habitable zone for humans to leave planet Earth to find another place. So that's the premise. And the idea is they're going to go through a wormhole, and we don't know what that's going to be on the other side of the wormhole. The intent in the wormhole is to get there faster, wherever they're going. And on the other side, potentially, they got black holes. And black holes could suck you all in. We don't know what's going to happen. So that's the rest of the story. You're going to have to go and see that movie.
Were you a consultant on this?
No, I was not a consultant. But the interesting thing is, that's the movie version. The reality version is NASA, as you know, sent out a Kepler mission a few years ago, and that's gone to the far reaches of outer space. And allegedly, Kepler has found the habitable zone. This is called the Goldilocks zone, by the way. And that's the good news. And in fact, it turns out those planets, in fact, there's a few planets out there, they look just like Earth. They have allegedly, potentially, the atmosphere that we've got, the water, et cetera. So the Goldilocks zone. That's the good news that NASA is telling us. The bad news is that it's 12 light years away. So the 12 light years basically means, and those of you that have had physics in school, 186,000 miles per second. Now you can start doing the math as to how many years it's going to take for us to get to where the habitable zone is. So we got what we got right now. And in fact, we've heard this morning, Dr. Merrigan and the secretary and the panelists earlier talked about all the challenges that we've got as well. We got what we've got. We're going to have to figure out how we're going to go ahead and feed the world.
Before we talk about some of the interesting that we got, do you think one day that we will be growing crops outside on some planet or stars far away from here?
Well, it's going to be way out in the future, at least way beyond, I think, all of our multiple lifetimes. Now, NASA, of course, is deeply interested in this. In fact, multiple agencies have provided funding for their work. We have provided funding at many of the land-grant universities as well to figure out self-contained food production systems and things like that. For example, the potential for growing food in self-contained systems on our moon, on Earth's moon, on the space station, for example. Potentially, if we were going to be able to take off and go to Mars. So there is that possibility. But I think it's many, many years out. I think at least in the, foreseeable future, which is way out there, we got what we got.
So on Earth, there's a lot of action in the water, right? People want to grow things in the water. Why don't you talk about some of the cutting edge things to expand actually the space that you can grow on?
Yeah. So there's multiple domains in thinking of expanding the space and also in regards to water itself. Now, expanding the domain could be, for example, we've had actually research that's been done, and people have actually put it into practice in regards to vertical farming, for example, and tall buildings, and that's a good possibility. Current technology allows us to grow lettuce and maybe some tomatoes. And I've even joked that maybe we can create them into aquaria so you can grow fish, for example, to meet our protein needs and things like that. But really the bottom line is agriculture as we see it, the farm that you and I would recognize, the Norman Rockwell type farm, is going to be that horizontal farming that we need. And we'll continue to have that, in part because we've got to have calories, in part because we've got to have protein as well. For the most part, calories and protein are going to grow on that. And then we've got to have the nutrients as well. Those would be the fruit and vegetables and things like that. Current technology is on that horizontal space.
How is the Norman Rockwell farm changed? It's more mechanized?
Oh, gosh. Yes. So, yeah, if I said the Norman Rockwell farm, or just ask the word farm, what's it mean to you? The average person on the street would think, well, it's got these beautiful rolling hills, green pastures, a red barn maybe, a guy typically wearing bib overalls, and maybe there's an old tractor in the background there, an Oliver or some such thing that's in the background as well. And that's the sort of the 20th century farms. And in the latter part of the 20th century farms, we started getting, precision farming and things like that, incorporation of geopositioning satellite systems onto our tractors and combines, all that started as well. So there's much more precision. The 21st century farm, in contrast, is very different. You still have to have that land, the rolling hills, the barn in the background.
How about the overalls?
Yeah, the overalls could be there, indeed, absolutely. You want to have that. But the farmer, by the way, is a data manager today. They're being inundated with data. There are all manners of sensors, for example, in the ground, in the water, in the lagoons, in the plants themselves, for example. You've got all these sensors that are emitting the current state of affairs in that particular environment. You've got drones that are flying around picking up information about the status of that crop or the livestock animal that you've got. We have seen the development of Roomba-like devices. And again, we provided funding for that. That goes underneath the crop canopy. It's picking up the smells of maybe insects and pathogens and weeds and things like that, and incorporating all of that. That needs to come in, and the farmers can sit at their, with their handheld devices, for example, and they're becoming data users, basically, information users. And that's the farm that we've got today. It's way beyond just having a GPS system on one's a combine or tractor.
So let's talk about some of the robots and some of the more interesting things that are in your labs. You're funding all these different labs. So sensors, what's the next generation that you're seeding right now?
Yeah, so the next generation of sensors, for example, are what are referred to as biomems devices. So you got a biological piece and a mechanical, electromechanical piece that are combined together and using nanotechnology approaches. And so these biomems devices can be part of a leaf or can be in the ground itself. And it is picking up the environmental conditions and emitting. So a plant might be impacted by a pathogen, for example, and the leaf color changes from green to some other color that signals to the farmer saying that something needs to be done. So that's coming down the pike here in just a few years. Professor Medford, June Medford at Colorado State University is doing some of that kind of work currently in developing these sorts of sensors. Along with that, we've got, we're all using the Wi-Fi. In fact, the audience here is probably sitting here using the Wi-Fi, the Washington Post Wi-Fi, and tweeting and posting on Facebook and things like that. Farms today are chock full of Wi-Fi routers and things like that too.
And how does it help? For example, it can do what? It can.
Yeah. So it can give you the status of what's going on in that particular farm, for example. Let's say that you've got a dairy farm and you got a lagoon, which is where you got the manure that's going to be stored, and you want to be monitoring the status of that lagoon itself in regards to maybe the particulates that might be emitted into the air, the amount of ammonia that's coming out of that, in regards to the pathogens that might be out and about in there as well. You can have these signals, these sensors picking that up and then signaling that out to the farmer who might be doing other things, and then he or she could go ahead and deploy the appropriate remedial measures on that particular lagoon, for example.
You brought up pathogens several times, and it's an important thing. How worried are you that some disease will come and wipe out a considerable part of crops?
Yeah.
Especially with climate change and changing insects.
Sure. So we have a history already, right? Humanity has a history. The Irish potato famine, for example, of the mid-1800s, which really changed global history, world history. In fact, America's history is in large measure the result of the Irish potato famine, in part because when potatoes were taken from the New World, that is from the Andes in South America, to the rest of the world, it was it's clonally propagated. That is, potatoes are propagated by cutting pieces of it, and then you plant that little piece, and it'll bud out, and you get the plant. That's called clonal propagation, so everybody's related. And a consequence of that is those potatoes were susceptible to this particularly vexing disease. It's the Irish potato blight that we've got. And that's what happened back 150 years, 160 years ago. Fast forward to today, we've got potentially a large, in fact, potatoes, again, are being subjected to the same pathogen, we got to be worried about that, in part being driven by climate change and other considerations. A large population of the world ends up eating plantains and bananas as part of their staple crop. And there's a vexing disease in there called Sigatoka disease. And that Sigatoka disease, again, plantains and bananas are also clonally propagated. Instead of a tuber, you've got what's called a corm, C-O-R-M. And you chop that up and you plant that and you get banana plants, plantain plants. And so again, Sigatoka disease is because we're clonally propagating, waiting to be a disaster. Third one is we have a disease called UG99. It is, again, potentially a devastating disease on our wheats. When Norman Borlaug, the father of the Green Revolution, by the way, I'm one of the recipients of those 1 billion people that were fed by Norman Borlaug growing up in India. When he developed the wheats, they were able to deal with these pathogens like rust, stem rust and things like that in wheat. Now we've got UG99, totally new, and in fact Norman Borlaug, just before he passed away, he was very concerned that we may not have the ability to deal with this particular rust that's coming down the pike. Although in the recent past, we've fixed that.
Two things. How worried are you about these pathogens, and how do you guard against them?
Sure. All of us need to be concerned about this, no doubt about it. In part because of the globalization of our enterprise that we've got. We've got movement of people, movement of food materials, movement of animals, movement of insects and things like that. And in fact, insects are a great aerial device to get pathogens around. You know, flies and other insects can carry these things, aphids or crickets or locusts or whatever you've got. In fact, insects, for all intents and purposes, are like a cow. A cow has multiple stomachs, right? They have a ruminant stomach, as we call it. Insects have the same thing. They cannot digest the cellulose, the green plant material, so they have to rely on the intestinal microbes to do that. So insects can be carrying these things as well. So we need to be very concerned about it.
And climate change, changing where?
Absolutely.
Which kinds and what part of the year insects are coming, right?
Absolutely. As the Secretary mentioned as well earlier in his comments, you know, the growing seasons are getting elongated. And we've got plants being exposed to insects and pathogens and weeds and things like that. They ordinarily would not. In fact, in wheat production systems in the Midwest, in Kansas, over the last many decades, we figured out what we refer to as a cultural control practice. There's a particularly nasty insect on wheat called the Hessian fly. And you can very simply move your growing season just a tad bit by about 2 weeks and avoid having the insect problem.
So that's the next question. So moving, more knowledge about when these are coming. How else do you guard against?
Okay, so right off the top, it is that knowledge that we need. We need to make the research investments to get a better understanding of the ecological connections between organisms, pathogens, and how plants and animals react to these new pathogens coming. That's absolutely a must that we got to have. Beyond that, we're going to have be investing in these first responder alert systems as well. I was referring to these sensors and things like that. We've got the technology today to get to that point. Give you an example. You know what food safety problems are. You eat some food in some places and you may get as we call it, deli belly or Montezuma's revenge or whatever else that you might get. And one of those pathogens that causes food safety problems in us is referred to as listeria. Okay, and this listeria is a particularly nasty bug. And there's some work that's been done in the very recent past in Boston, Massachusetts, where they have taken what are referred to as bacteriophages. Bacteriophage, the name should tell you something. Phage, P-H-A-G-E, means eat. Bacterio is bacteria. These are viruses that go ahead, eat bacteria. And what these folks have done is to incorporate into it a gene that allows them to detect the occurrence of listeria, and they light up. They get eliminated. Now, the method that we use today to find listeria takes us about 24 hours. This lighting up system takes 3 hours. Imagine the possibilities of developing systems and technologies of that sort. The third,
and the difference between the 3 hours and the old way is what? I mean, what's the
oh gosh,
end game?
it could be just a few individuals becoming sick versus hundreds of thousands of people becoming sick. You know, when you go to restaurants, for example, because people aren't washing their hands, or you got contamination through the produce or the meat or whatever else that you've got, you could potentially end up having, in quotes, an epidemic that could happen as well. You know, look at the situation we had with the spinach
Right, right.
and the jalapeno peppers and things like that.
Let me ask you one more question, then I'll go to Allison. You've talked a lot about the Internet of Things coming to agriculture and how all things will be connected. You want to talk a little bit more about that?
Yeah. So the Internet of Things is basically the interconnectedness of everything that we've got. And we're all walking around emitting sensors. We got emitting sensors on these things, every one of us. All this is being connected, interconnected, on and on and on. That's our life today. The Internet of Agricultural Things is that in the agricultural world as well. From the farm, I was talking about all these sensors we've got, all the way to your dinner table. The refrigerator has sensors on it that can detect, tell you that your milk is going to be going out of date or your meat's going to be rotting. In fact, we provided funding to folks at the University of Arizona that are creating these shrink wraps that will turn color if the meat goes bad, spoils, and that'll send a signal to you, for example, that you can pick up. And so,
well, can it do it a day before so you can use it and it won't go bad?
Indeed. I mean, it's constantly pinging you, in quotes, pinging your handheld devices to let you know that, you better watch it. You might be having to go ahead and dump it in the trash. And we heard earlier about
and we're going to talk
food loss.
for a whole panel this afternoon. It's such a shocking amount of food that's wasted. We'll go to Allison.
On the subject of pathogens, can you talk a little bit about the role of human disease, for example, Ebola, and food security?
Yeah. Interestingly, the technology that resulted in the Ebola vaccine that helped save some of our own American doctors that were infected, that vaccine is developed by a company called ZMapp, and that's grown, in quotes, in tobacco plants. The technology for that, the underlying technology, my agency provided funding to a Dr. Charlie Arntzen, who is now at Arizona State University, whose invention resulted in that vaccine, the ability to develop that vaccine. So the challenge is that we've got people in the West Africa, for example, who are being subjected to Ebola, and they're many of them living in rural communities. They're farmers, for example. They're not able to go and tend their farms, and you've got a whole host of issues pertaining to the fact that people are too sick to be able to go and grow the food, or transport it, or sell it, or move it around. All of these are being affected.
As you move around the world, there's been talk about how we can't replicate what we're doing in the States elsewhere, and we can learn from other places. What are we learning in terms of innovative things, perhaps in places that don't get a lot of, for a very long time, have had droughts? And what are we learning from China or Brazil?
Yeah, sure. I mean, a lot of things. We're constantly learning. I mean, the science itself is an international enterprise. It's a global enterprise, just like everything else that we've got as well. A couple of examples of that is in the good old days, about 5 years ago, 10 years ago, when we worked to understand the genome, the genetic sequence of plants and animals. It was done at what we refer to as the Joint Genome Institute that is supported by the U.S. Department of Energy in the United States. That's 5 years ago. You fast forward today, you want to do that work, you go to BGI, Beijing Genomics Institute in China, because they are the players. So we're sending our plants and animals to partially be sequenced over there as well. So there is that knowledge that's coming back to us from China, for example. The Australians and Brazilians are now, competing on the global marketplace, as it were, in science and the ability to provide food, whether it's drought resistance or the ability to tolerate high temperatures in animals and plants. Knowledge of that sort is coming back to the United States. In fact, there's a fellow sitting in front of us here, Angus Murphy, who's a professor at the University of Maryland. He's a plant scientist, and he collaborates with scientists in many parts of the world, and his own work is on the hormones that help plants grow. And so he's learning from those scientists out there in China and in Brazil and other places.
So we have two last questions, and then we're going to break for lunch. But the land-grant universities have played such an important role in research. And around the world, can you talk about, it seems key that if there were similar land-grant universities in Africa, for instance, it might lift that continent, which needs so much help.
Earlier, you heard Trent McKnight eloquently speak to the land-grant universities and the tripartite mission of research, extension, and teaching that's part of our land-grant universities. We also heard earlier about the Green Revolution. And part of that green revolution, particularly in Brazil, in South Asia, I'm from South Asia, from India, was the fact that American land grants 50, 60 years ago went to India, established, helped build land grant universities from the bottom up.
And just for those who don't know, the connection between and the importance of land grant for agriculture.
Yeah. So the land grant universities has inherent in it. One is the education of young people in the agricultural and mechanic arts. That's one piece of it. That's the agricultural and the engineering aspects of it. The second is to discover new knowledge to help grow food or help human beings be human beings, for example, from a nutrition perspective or whatever else we've got. And the third piece of it is that knowledge doesn't sit on a bookshelf. That needs to be translated into innovations, and that's done by our extension folks. That you heard that terminology before as well. Cooperative Extension Service translates that knowledge into innovations in the form of solutions and delivers it to the end
So it's been
users.
critical in the development of this country. So
Absolutely.
you were saying that, so we went to India and it's been successful there?
Yeah.
And now what? Now
And now, in fact, the United States is deeply involved in, earlier you had asked the question of Secretary Glickman and Secretary Vilsack as well. You heard my colleague Sahara Moon Shepatin in USAID, Agency for International Development. There's efforts of the sort where American institutions such as Michigan State University, Ohio State University, and others, these land grant universities have been working with USAID to help establish that capacity and that infrastructure on the African continent and in some of the Asian countries as well now. I mean, that sort of work is going on
where it's
now.
happening.
Yeah.
Okay, so 10 years from now, when we ask the same question, we're looking at this rise in global population and worry about an equitable system of healthy food for everyone. How will it be different from where we are sitting today?
Yeah, well, I mean, how will it be different? One is earlier, my boss, the Secretary Vilsack, referred to soil health. The year 2015 is the United Nations International Year of Soils because the soil, there's a saying in West Africa, for example, and in East Africa, that the soil is tired. And that's absolutely true. The soil is tired in a lot of different places. That rejuvenation of that soil needs to take place. In about 10 to 15 years, we'll see that rejuvenation and the ability to resurrect that soil to be able to grow our crops. That's one example.
So the attention on soil will have made a difference.
Absolutely. A second one is you heard Secretary Glickman refer to the need to have varieties of crops and animals that can withstand climate change, the high temperatures, the droughts that we're seeing, and the ability to utilize nitrogen, for example, more efficiently as well. That's going to be a done deal in the next about 10 to 15 years. A third example, we have two kinds of plants. One is referred to as, all plants, as you know, they photosynthesize. They take solar energy and other, carbon and water and oxygen, et cetera. They make carbohydrates, sugars. And there are two styles in plants that have evolved. One, they're referred to as C4 photosynthetic plants. C4, exemplified by corn, maize, can make 2 times as much sugars for the same amount of input. C3 plants, like rice, can only make half the amount that the corn plant can do. If we can understand how corn plants are photosynthesizing and apply that knowledge into your rice, imagine the rice production systems that we've got, the paddies that we grow it in. We can reduce the amount of water used. We can reduce the amount of methane because it's an anaerobic condition under which rice is grown. We can reduce the amount of land that goes to rice production, et cetera, et cetera, et cetera. I'm going to put my money on the table that we're going to have that figured out in the next 10 to 15 years. I'm relying on guys like Angus Murphy and other plant scientists across the world.
So you're optimistic that we'll be in a better place?
Absolutely, absolutely optimistic. But along with that optimism, of course, there's a lot of low-hanging fruit that's been referred to earlier about food waste and food loss, for example. The education piece of it, not just education of the scientific community, but also we got to have more. We heard that earlier. Aging population, farm population, not just in the United States, but globally it's an aging farm population. In fact, we're becoming a world of wusses. People don't want to go work in the hot sun in the cold winter as farmers. and we got to resurrect that and bring young people back in. So it's not, education piece is about the farmers that we need, about the scientists that we need. Oh, by the way, those translators of that knowledge, the extension folks, in America, we've lost a third of that footprint because of the economic downturn in the last 10 years. And so we're going to have to fix that as well, change that around as well, that we're going to have extension. We heard earlier
Are
about...
we going to fix the WUS problem in the next 10 years?
I'm going to say that. So you heard Trent McKnight refer to FFA. There's another community referred to as 4-H. Maybe some of you were members of 4-H when you're growing up. And we have 7 million children in there. We have another educational program called, and Kathleen Merrigan's favorite enterprise, Agriculture in the Classroom, and we've got about 5.5 million children in there. And the intent behind that is to help them develop a better knowledge about where food comes from, and so they can indeed become less of a wuss and go and work in that hot sun in the cold winter.